Good evening, everyone, and thank you for joining us. The first Kubernetes meetup here at the True office. Thank you. We have two talks tonight. The first is our own cosmonaut, Alexander. He's going to talk about building Kubernetes as a service at True and what we encountered. We have Leon from JFrog, who's going to talk about a Kubernetes-powered Go modules repository.
Welcome to True. I'm Cherakov Alexander. I'm going to talk about Kubernetes as a service, how we are building it, what we have built, and what were our decisions when we were building our Kubernetes at True. I will tell you a little bit. True is a managed hosting company, so we're not simply host the websites. We do manage how your website is running, so we're responsible for your stability, what kind of performance you have, and so we're doing the dirty stuff of your applications. We are currently working on our new product. It is managed Kubernetes, and here is the agenda for today. I'll talk about our requirements, what we expect from Kubernetes as a service and as a managed Kubernetes. I'll talk to you about our choices we select for provisioning. I'll talk about our current configuration and what we have right now and what we think we would implement in future. I will talk about operational problems you can meet, what kind of things you should do when you're running Kubernetes as a service. And after it, we will have some Q&A. If you have some questions for me about our implementation, how it is working, and maybe some else. Okay, the first one, our requirements. We want to have Kubernetes up and running almost instantly, so as you usually do in Google Cloud, in Azure, in DigitalOcean, in any other cloud providers. So you select the nodes, you select the version, and up and running. That's all. Nothing more. We want to be able to deploy it on our own in-house development. It is called Highlander. We are not using cloud providers. We are not using OpenStack. It appeared before cloud solutions appeared, so that's why we stick with it. Maybe we will decide to go something else, but our platform more than 10 years old, and it's more than 15, I think, even. And it suits all our requirements. We want to have ability to deploy applications from the beginning, so we deploy the cluster, and it already have configured everything. So major problems when you're deploying the provider, your cluster, you don't have external resources like persistent volumes and allocation of extra IPv4 or addresses. So yeah, we need to solve it somehow. We want to have an ability to upgrade to our cluster to the next Kubernetes version. Yeah, it's pretty important because Kubernetes is evolving really fast, and without doing upgrades, we will stick with the version which will be unsupported in half a year or year. We really want to have ability to run Kubernetes HA mode. However, we think that in most cases, you don't need to run Kubernetes in HA mode, because there is no need. Application would continue to run, but if you're running multiple etcd databases on background, it really working slowly. And if you're running multiple API servers, you need to have some kind of load balancer. So yeah, it is overcomplications, but for some customers who require very big stability of Kubernetes control plane, yeah, we want to have it. So it is one of our requirements. And it's one of the really big wishes. We don't want to create additional accounts for every user we have in our Kubernetes. So we already have our platform. We already have accounts there. We don't want, and we want to reuse accounts from our system in our platform. What is our expectations as a managed container services? We want to have ability to get the code from our clients and to pre-build images, Docker images or container images using CI/CD pipelines, deploy it, and run applications without running any interruptions. For the popular CMS systems, we want to have also already have some kind of, because a lot of people are running WordPress, a lot of people running some kind of existing blog systems, and everyone do not want to rebuild every time the same stuff, and we are going to do it in advance. For the security reasons, we want to have ability to audit, so every big cloud have ability to store the images before you are going to push them to your Kubernetes cluster. It does give us ability to integrate it with CI/CD pipelines, so when you are running build image and then deploy it, but you need to store it somewhere, and we need to have some kind of storage where we're going to store it. It allows us to make an audit of these containers for the security flows, like recently was problem with Node.js, and it is when you're building the image, you are building from the maybe outdated image with outdated SSL packages, also a problem. So security audit is also one of the problems we are going to solve. For our support guys who is doing the dirt job, it is really important to have unified monitoring, logging, and the configuration of the system. We want to have ability to integrate all metrics from all applications to one single monitoring systems. Same for logging. And the next one, it is tracing of requests. I think it is really important for people who is designing and looking what's going wrong with applications. We want to have ability to trace the requests, so we need to add some kind of trackers to every request coming in and trace it down through the microservices or something else. And of course, we want automatic scaling of worker nodes depending on load. If load is going high, we want to scale it up. If load going down, we want to scale down. And this is what we want to have. So what we considered as the solutions to provision clusters. There are a lot of solutions to provision, but we considered few of them. I think it is not only choices. First of all, it is our own provisioner. It is KubeSpray or any kind of standalone stuff applications, and Rancher. It is almost vendor distribution of Kubernetes, which gives us a lot of control. So with own provisioner, what you need to do? You need to do everything, but you would get everything. It is pretty easy choice, but you need to implement really how you're going to run the control planes, how you're going to run a etcd. You need to generate all certificates. You need to have all control plane configured by hands. It is not that hard, but when you're going to details and you're looking at, okay, I configured everything, and I'm starting containers, but it is not working because networking is missing. And here is going with every small parts of Kubernetes. It is so modular, but it is so simple, I can say. But because of modules you are using every time, it has become more complex from day-to-day life, and with every new features, you need to solve new problems. Yes, I think it is very good when you are trying to build your very precise and custom solutions with enabled features which are not enabled by default in some distributions, or you want to have some unique configurations with enabled or disabled authentication, for example, or something else. So it is option, but we decided to try also KubeSpray, which is a really good project. It is official Kubernetes project to deploy clusters. It is Ansible based, which is really great because we are using Ansible inside our company to configure our servers. And it is really easy to extend because of Ansible. You're simply adding one more role, one more task, and you're ready to go with new features which you are missing in base Kubernetes. But on the other side, it doesn't support out-of-the-box external authentication, so we can't use our SAML accounts, and yeah, it doesn't work. We need to add something inside. It doesn't have interactive UI. Yes, we can add Kubernetes dashboard, but it is not what we expected. It's still the UI to control one single cluster. So yeah, the next point, no multi-cluster support from the box. And no upgrades, not really an issue. You can do upgrades with KubeSpray, but maybe, yeah, we run into some issues with running upgrades using KubeSpray. Maybe it is because of us, maybe something wasn't working very well. Next one, we tried to use Rancher. Rancher, it is really good solution. They have enterprise level of support, so we can ask them about everything, how Kubernetes is working, how we can solve our problems with Kubernetes. It has UI, which allows us to control multiple clusters at the same time. And it is pretty simple to control it. So you have a CLI built in, so you don't need to configure your local kubectl to access the cluster. It has multi-cluster support, which is really important for us. And we can use our True accounts to log in to the Rancher, because it has pluggable authentication system that supports ODAP and something else except SAML. And it have easy Kubernetes upgrades, which you simply select in drop-down list what kind of Kubernetes version you want to run, and it is upgrading first control plane, and after it, it's upgrading worker nodes. But Rancher itself, it is pretty big distribution, so it comes with some kind of disadvantages also. It is running a Rancher agent, which is running on every cluster controlled by Rancher. If something happens with this agent, your cluster is not working anymore. You need to restart to fix it, and only when Rancher agent restarted and fixed it, you can control cluster again. Yes, everything which is running in cluster continues to run as usual because Rancher agent doesn't affect it, but because Rancher, when you do control your cluster from Rancher, you are connecting through Rancher endpoint, and then it is bypassing to the cluster. So it is a really big disadvantage, especially in our case when we are going to run hundreds of clusters inside it. Single entry point, not the best way to do it. We were expecting to have separate entry points, but it is not how they did it. Also, VM requirements for the running Rancher itself is pretty high, and when you are running more than few clusters, it is going even higher. When we started up more than 10 clusters, we run into issues that Rancher running out of memory. However, we were running it on the bigger VM, and yeah, when we asked Rancher, they said, yes, more clusters you have, more memory and CPU you should ship to the Rancher cluster, which is supporting everything. The next 3 points is not really crucial and important for everyone, but when we considered it hard to maintain more than several servers, clusters, not really a big issue, especially with upcoming version. I think they solved it with grouping clusters and adding search. But in current version which we are running, it is pretty hard to select a required cluster. It is not possible to enable or disable Kubernetes features from the Rancher UI. It is caveats of running the vendor distributions because you are running Kubernetes as a vendor seed, not how you want to run it. And of course, it doesn't have an integration with our VDS platform. it is not that a problem because Rancher supports Pluggable for adding more cloud providers, and we can write our own controller. Yes, we still need to write it, but it is solvable. So yeah, well, we need to write it anyway for any solution. So the next slide, it is about our current configuration. So in every cluster we are running everything. So we're running API server, scheduler, controller, etc database, and this node with the servers, of course, not schedulable because we don't want to workloads which are running on real servers, few disk space, or possible CPU, or do something else which would affect the whole cluster. Yeah, it is not. Yeah, you have control of all your components. You can do whatever you want. But we don't want to ask our client, please run a small server, which is not usable by you, only to run the control plane. What we really want to have, we want to have API server, scheduler, and controller running on our own cluster, where we can easily control it. So we can do backups, we can do monitoring on them. Yeah, we can do monitoring in any configuration, but here it is much easier because it is done by Prometheus Discovery, and we can add the labels by the customer. And customer's clusters is pretty simple. It contains only kubelet, which is connecting to API server. It has required services to run inside the cluster, and it allows, it gives more resources for people to run their workload. What configuration to choose? It is really depending on your needs. This configuration is harder to set up. It is harder to maintain. Mostly because you need to switch between clusters to understand what's going on with the cluster, and maybe there are some caveats when you need to access etc database. Yeah, you shouldn't do it in general. But if you want to access etc database from your cluster, it is not so easy. Okay, the next part, it is our operational, problems you need to solve when you run Kubernetes cluster, what you need to think about when you have Kubernetes cluster deployed. It is expecting to give some get some resources from external. And you need to write them down, and so you need to understand how much this cluster consumes of external resources, not only external power of VMs. So the first one, it is incoming connections. So by incoming connection, I mean traffic and additional IP addresses which you are going to serve. Right now in our beta platform, we solved the service with type load balancer with Metal LB. So we're pre-allocating some address space for every cluster, I think 5 IP addresses to be usable for every cluster. And it can allocate extra services, extra IP on request. And for incoming connections, we are using currently Nginx ingress controller. But for the production, we are looking to do either HA proxy with writing our own controller, or maybe there is existing, I haven't found it yet, to build layer 4 incoming traffic. So yeah, when you are requesting load balancer, you are getting layer 4. I think it is obvious. For persistent storage, you need to also, the main problem with load balancing, you need to understand how much IP addresses you are using, and how much traffic you are getting on this IP addresses. So we need to integrate it with NetFlow collectors who is receiving traffic for this IP addresses of the cluster. So we need to understand how much it is traffic it gets inside and sends back. Yeah, it is not as obvious, but yeah, we need to integrate our requests for IP in this space with our metrics and monitoring systems. Same with the persistent storage. Every cluster which you are deploying requires persistent storage. Either you are deploying it using Rook or you are using something external. We are using Ceph right now, and we are looking at NetApp with Trident plugin to give persistent volumes for the clusters. The main problem here, when you are running the platform of persistent storage, you need to grant permissions only to allocate volumes of this particular cluster. So you should mess with permissions, because there is very common ways that create permission system, grant admin rights, and ready to go. It is not working when you are running the same storage across multiple clusters, and you should dedicate clusters, you should dedicate persistent volumes to certain account which created it and not allow to interconnect them. The next major pain point of these persistent volumes is backups. Backups are really important, and there are several types of admins who are not doing backup yet, who already doing backups, and who is doing and checking that backups contains really working data. Because yeah, when you have backup, it doesn't really mean that you can recover to the previous system, previous state. So yeah, persistent volume backups is pretty easy. Every block storage has the ability to do snapshots, but when you delete your persistent volumes in Kubernetes, it is get deleted also from block storage. So and your snapshots which you created are really useless with it. We are using two types of backups. It is snapshots for block storage and files backup, which we implemented using Restic. First, we take a look at Stash solution by AppsCode. It is working really well, but it doesn't allow us to run commands before running backup. So we need to hack into it and change the behavior. So we decided, let's try to do something our own, so it would fit our requirements of backups, and not to have two different solutions, one for files and one for databases. So we decided to go with Restic for it. And for files, we are doing simple file backups, and for databases, we are performing first database dump and then backup the dump file. It is working very well. Restic supports encrypted backups, so you have keys in the cluster and backups are stored somewhere else. Next one about the logging, monitoring, and how to graph it. We are using Prometheus for monitoring. I think it is obvious. Everyone is using Prometheus for monitoring of Kubernetes. We are thinking about using Prometheus operator to deploy Prometheus on customers' clusters, because right now we are deploying from Helm chart. For logging, we decided to go with Loki, which is much faster than current EOCast stack, and it is working very well, as we have seen. For running Loki, we are running already Grafana 6. It is in beta right now. I think they released it a week or two ago, the Grafana 6 beta. And the major point with all this monitoring and logging stuff, when you're running multiple clusters with multiple applications, usually you are running the same Redis, the same MySQL, the same Memcache and other services, and they have the same metrics. And for this one, we were required to create application templates for every applications which we are running. So we don't reinvent every time metrics and dashboards and everything else for see what's going on the customer cluster. Yeah, it helps a lot for our support engineers who are working on supporting this the customer applications, and I think it is really important for everyone who is running Kubernetes on-premise to do templates for applications which are used in your environment. Okay, I think it is the last slide. Yes. So if you have questions about how we build it, what kind of solutions we chosen. So questions?
The aim with your platform, is that to support a single version of Kubernetes? Is your goal to force upgrades upon your customers?
No, we support multiple versions of Kubernetes, but yeah, because we are responsible for running customers' clusters, and we are working tightly with customers on how their application is working. We don't want to stick with one version, but yeah, it is Rancher which we are running. It has support of multiple versions of Kubernetes.
Multiple versions also means multiple configurations in that case.
What do you mean by configurations?
Well, if say customer B wants to use wants to use an F5 load balancer instead of Metal ILB.
Yes, it is possible. Usually we are building the most suitable solution. So if customer A thinks he wants HA proxy, customer B thinks he wants F5. Yeah, we can do it.
Okay, thank you.
Yeah, because we are running our, we have load balancers inside True already platform because we are running a hosting platform. So it is possible.
Thank you, Alexander.
Yeah. Thank you. Yeah.
Amazing.